everyone, welcome to Solid Academy. So now we will move to sets revision. A set is a first of all, what is a set? A set is a collection of well-defined objects. For example, A is equals to 1, 2, 3, 4, 5. This is a set. It is a collection of a well-defined objects. This set is denoted by means can be classified by into two, that is your roster form and set builder form. Roster form and set builder form. Set builder method. Okay, what is roster method and set builder? In roster method we list all the elements of the set. Here we list all the elements of the set. For example, A is equals to A comma B comma C, Z is equals to 1 comma 4 comma 7. We list all the elements of the set. For example, I'll take another example. Okay, if A is represented here as 2, 4, 6, 8, 10, like this. If A is in set builder form, we have to build the set. Here it is already built, that is called roster form, but in set builder form we have to build the set. How to build the set? Okay, we have to build the set. Okay, how to build? X is such that, we have seen such that symbol. X is such that x is multiple of 2. Multiple of 2 means I can write x is equals to 2n. Okay, x is equal to, x is such that x is equals to 2n, and n is less than or equal to 5. N is less than or equal to 5, comma, again we have to take comma, n belongs to natural numbers. N belongs to, this is set builder form. It is so simple. Okay, next, this was about identification of the set and the how to build the set we have seen. Next important topic is that singleton. First we will see types of set. First type of set is null set, void set, or empty set. Null set, void set, or, and what is null set, void set, or empty sets? Means A has no elements, no elements in it. It is denoted by phi. In all competitive examinations they will give you like this. Which is the right representation? The question will be which is the right representation for the null set, void set, or empty set. Option A will be like this. Option B will be like this. It is a more than one correct type question. Option C will be like this, and option D will be like this. Which will you mark? The right one here is B and C, because here phi itself is, this symbol is called phi, phi. This symbol itself is element, it is acting as an element here. Okay, so this thing will be a wrong, this thing will be wrong, and this thing will also be, because 0 is also a element, it is acting as an element here, but this thing and this thing are right. Is this clear? Very important. Null set, void set, or empty set. Next set, singleton set. What is singleton set? A set which has only one element, A, only one element, or B is equals to 4, only one element. For example, A is equals to x such that x is equals to 2n, comma, n belongs to 1, means it has only A is equals to 2 is the answer for this. Clear? Easy? Okay, done. Next type of set is equal sets. Equal sets. What is equal sets? Two sets A and B are said to be equal if and only if one more symbol. Here we will learn one more symbol, that is IFF, which implies if and only if. Means it is a must condition. Okay, if and only if is a must condition. Right. If and only if all the elements of A are also all the elements of B. If A is equals to 1, 2, 3 and B is equals to 1, 2, 3, then A is equal to B. Equal sets. A is equals to B. Equal sets. These are called as equal sets. Next, cardinal number of the set. Here I am teaching all the important points to be remembered, which the examiners will use in their questions. Okay, we have to remember the terms and these things. Okay, cardinal number of a set. What is cardinal number of a set? If A is equals to 1, 2, 3, 4 and B is equals to 4, 5, 7, then cardinal number of the set is represented by n of A. N of A is 4. The number of elements in set A is a cardinal number of set, and here n of B is 3. Okay, for B. Okay, that was the thing. Cardinal number of sets. Next we will move to subset. Very important, most used things. Most important topic, subset. Okay, what is a subset? A set A is said to be subset of B if every element of A is also the element of B. A set A is said to be a subset of B. A set A is said to be a subset of B if every element of A is also the element of B. If A is equals to 1, 2, 3 and B is equals to 1, 2, 3, 4, 5, every element of A is also the element of B. Every element of A is also the element of B, then A is subset of B. Then A is the subset of B. One more example. If B is equals to, again the same, 1, 2, 3, 4, 5 and C is equals to 10, 5, 4, 6, sorry 8 for a while, okay, 4, 8, 3, 2, 1. Again B is subset of C because all the elements in B are present in A. 1 is here, 1 is here, 2 is here and 2 is also here, 3 is here, 3 is here. I am not taken 3, okay, 3. 3 is here and 3 is also here. 4 is here, 4 is here. I have taken 3 here. Let it be. Sorry for the inconvenience. 5 is here and 5 is also here. Then B is called subset of C. Is C the subset of B? This statement will be wrong. C will never be the subset of. If all the elements present in C are the element of B, no. 10 is extra, 8 is extra. So it cannot be the subset. Is this clear? Most important. And every set is subset to itself. C is subset of C. C can be subset. This is subset symbol. C is subset of C. Subset is denoted like this. Subset is denoted like this. Subset. C will be the subset of C always. C is subset of C always. Next. Empty set is subset to every set. What is empty set? A is equals to 5 or A is equals to void set is called empty set. Okay, this set, this A is subset of every set. A subset means empty set is subset of every set. Proper subset. Now we will see proper subset. What is a proper subset? Let A and B be the two sets. If A is a subset of B and A not equal to B, then A is called proper subset. A must not be equal to B. For example, if A is equals to 1, 4, 5 and B is equals to 1, 4, 5, 7, then A is the proper subset of B. But here if I am adding right here if I am adding 5 and 7, then A is equal to B, then A is not a proper subset of B, then A will be not the proper subset of B. If A is subset of B and A equal to B, then it is called improper subset. Then this example is called improper subset. Improper subset. If I'll remove any one element from here, then it will be the proper subset. Okay, is this clear? Okay, now we will see closed intervals and open intervals. Okay, closed intervals and open intervals. See, for example, we have a number line. This is my number line. Zero, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. If A is the set which is equal to -4, -3, -2, -1, 0, 1, 2. If this is the subset, then it is included, all are included here, -1, 0, 1, 2, all are included. If all are included, inclusion will be depicted by dark circles. Inclusions will be depicted by dark circles. This will be a dark circle, and exclusion will be depicted by, for example, is 3 excluded? Yes, 3 is excluded. Then I will be taking open circle there. Open circle. Open circle. For example, if I am given, sorry, okay. For example, if I am taking any value of x which is -2 to -3, and it is like this. Okay, if this is my set which is from -2 to +3, and they are also telling us that -2 is equal, x can be equal to -2, but x cannot be equal to 3, x cannot be equal to 3. Is this clear? If that is the case, if that is the case, then here equal to symbol is there, then I have to use a dark circle at -2, dark circle at including. Here +3 it is only less than, then I will be using open circle and I'll join these two. This will be the thing. Okay, now otherwise in your board exams we have to depict here only dark circle, hollow circle and highlight it. Okay, that's it. This will be the including the parts and excluding the parts. In this same manner, if I want to depict it in a set form, points to be noted. Point number 1, square brackets shows me inclusion, means including. Open brackets shows excluding, and the points which we had learned just now is dark circle represents including and hollow circle represents excluding. Now if I want to represent this thing, in 1 and 2 format, then it will be represented by square bracket minus 2 because it is included, comma 3 because it is excluded, open bracket. This is called as closed bracket, and this is called as open bracket. This is called as open bracket. Is this clear? If this is clear, we will move to Venn diagram. Before moving to Venn diagram, we will move to the operations of set. Okay, right. Operations of set. What are the operations of set? Union of a set. First operation, union of a set, represented by u. If A is 1 2 3 and B is 1 4 5, then A union B will be equals to 1 2 3 4 and 5. 1 2 3 4 and 5. I think so you are getting it. Okay, next is intersection of sets. Intersection of sets. In intersection of sets, I am taking again the same example 1 2 3 and B is equals to 1 4 5. Intersection of set is A intersection B, denoted by ulta U. Okay, inverted U. A intersection B will be equals to the common elements in both the sets A and B, which is 1. I think so intersection and union is clear for you. If that is clear, we will move to difference of set. Difference of set. Difference of set. What is difference of set? In difference of set, if A is equals to 1 2 3, again the same example, and if B is equals to 1 4 5, then A minus B is 1 2 3 minus 1 4 5. 1 2 3 minus 1 4 5. We have to cancel the common elements here. Common elements here. If I cancel the common elements, 1 is the common element, then A minus B. After cancelling, what we have to do is, okay, after cancelling A minus B, we have cancelled A from B, then we have to write the remaining elements in A. If I am cancelling B from A, 1 4 5 minus 1 2 3, then 1 1 will get cancelled, and I have to write the remaining elements in B, 4 and 5. This will be the difference of the set. Next is Venn diagram, very important, which this Venn diagram will absolutely help you in all the things. Okay, very important Venn diagram. Let us see what is Venn diagram first. This will be a universal set. This is your universal set. If this is your universal set, we are learning Venn diagram. If A is all natural number and B is all whole numbers, all whole numbers, this is natural number and this B is whole numbers, then the sets in the Venn diagram, the sets in this is the universe, means all numbers, whole numbers, integers, everything is covered in my universe. Now sets are represented by circles. A is natural number and B is whole number, remember. And B is our whole number. This is our A, sorry, this is A in red and this is B in blue. This is A and this is B. This is all natural numbers and this is all whole numbers. All whole numbers. And this is all numbers. All numbers includes everything. So here we have only pure natural numbers. Okay, wait, I will take part sessions. If this is A, okay, I'll take this is X, Y and Z. What is X? Pure natural. Pure natural. What is Z? Pure whole number. And what is this intersection part? Which is common in both A and B. Which is common in both A and B. Which numbers are common in both A and B? All numbers are common in both A and B. Are all numbers are common in both A and B? Think and just pause the video. It is a recorded lecture. Pause the video and solve it. What are the numbers in X? What are the numbers in Y? And what are the numbers in Z? The numbers in X, Y, Z. What are the common numbers? All natural numbers are the whole numbers. We know that all natural numbers are our whole numbers. Are all whole numbers natural numbers? No. 0 is added to the natural number to become whole number. Means 0 is a whole number. Then at Z part we have 0. Only 0 at Z. What is at Y? All natural numbers. And what is at X? X is just a void. Okay. So here we are getting 3 parts. And in these 3 parts I will explain you the parts first of all. Y part, X part, Z part. Y part is A intersection B. This is A and this is B. X means this whole thing. X means this whole thing. Z means this whole thing. Y means only this thing. Okay. Are you clear about Venn diagram? Are you clear about Venn diagram? Next, complement of set. If U is the universal set 1, 4, 5, 7 and A is the set 1, 4 and A complement will be 5 and 7. Why? 1, 4 are present at the both universal and A. Then the only not presenting sets, absent sets at A are 5 and 7. Then the complement will be 5 and 7. Then the complement will be 5 and 7. Most important. Is this clear? Now, this topic is number of subsets. Number of subsets. Number of subset of A. Of A with n elements, which is equals to 2 to the power of n, which is equals to 2 to the power of n. If A is equals to ABC, it has 3 elements, n is equals to 3, 2 to the power of 3, number of subsets, number of proper subsets, number of proper subset, which is equals to 2 to the power of n minus 1, because 1 is set which is A itself, 1 is the set which is A itself, 2 to the power of n minus 1, 2 to the power of n minus 1, number of proper subset. Next is Cartesian product of sets. If A is equals to 1, 4, 5 and B is equal to 1, 2, that much only, then A cross B, Cartesian product of sets is A cross B, then A cross B is equals to all the elements of A with elements of B, 1 with 1 2, 4 with 1 2, 5 with 1 2, means here we will get the ordered pairs 1 comma 1, 1 comma 1 and 4 comma 1, 5 comma 1, 1 comma 2, 4 comma 2 and 5 comma 2. This is A cross B, this is A cross B. One more thing, most important thing to be remembered here, number of elements in A cross B means number of ordered pairs in A cross B, which is equals to number of elements in A into number of elements in B, number of elements in A into number of, here we have 3 elements in A and here we have 2 elements in B, then A cross B is 3 into 2, 6 elements we have, 1 2 3 1 2 3. Is that clear? Is that clear? So this was all about sets chapter, a quick revision which will of course help you. So thank you, and if this video finds you helpful only, then please subscribe. Keep learning.